And good morning to you. So the following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are 3 different classes that may be during this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. There you go. Okay, so the test, I will be correcting it today and updating scores if people get some partial credit or something. If you have questions about the test, email me and I will contact you. I'm not going to take regular class time to do that because you didn't all have the same numbers. So for me to do a specific problem, not everybody had those numbers. So it would be better to just deal with you one-on-one if you have questions. All right, moving on, we're going to go into chapter 5. Those of you that took Math 85 covered all of chapter 5, so this will be a review for you. Those of you that just tested into this, there are some important things at the beginning of chapter 5 that you will need. I will introduce those as needed. But today, we're going to start on section 5.4, and that's what we're going to do right now. Okay, so here we go, section, whoops. Let's see what's going on here. Oh, please, not again. There we go. Okay, it's working. I was going to panic there. Let's not have another Monday. All right. So, what is a monocle? I'm not even sure how you spell it. Monocle? Probably not. What's a monocle? Anybody know? Anybody ever watch Hogan's Heroes? Commandant Klink, he wore a monocle. No? Well, mono means 1. All right, I know you know the answer to this. How many wheels are on a bicycle?
2.
2. So a bicycle has 2 wheels. Bi means 2. How many wheels are on a tricycle?
3.
There you go. All right, so when we're talking about algebra, terms, expressions, whatever, we call them polynomials. Poly means many. We can have a monomial that has 1 term, like 4x squared y. We can have a binomial that has 2 terms, like 5x plus 7. We can have a trinomial that has 3 terms, like 3x squared plus 7x minus 2. That's a trinomial, okay? If we have more than 3 terms, like 4 or 5 or 6, we tend to just call them polynomials. In fact, we group all these together and call them polynomials. It kind of bothers me because a monomial only has 1 term and poly means many, but you'll see book after book that groups all of those, considers them all polynomials, okay? So a monomial has 1 term, a binomial has 2 terms, trinomial 3 terms. Anything beyond that is just referred to as a polynomial. Have any of you ever played the game Monopoly?
Yes, it's one of my favorites.
Except what's it called? It's called Monopoly, right? So it's 1 many. Yeah. Okay. Anyway, let's see here. So 3y minus 5. Is that a monomial, a binomial, a trinomial, or just a polynomial?
Binomial.
Binomial, 2 terms, right. Okay. So this is a binomial. lovely looking M. How about 9xy? Is that a monomial, binomial, trinomial? What is it? How many terms does it have?
Monomial.
One, so it's a monomial.
Okay.
Okay. How about 2x cubed minus 5x squared plus 6x minus 3? Monomial, binomial, trinomial, or none of these, just a polynomial?
Polynomial.
Polynomial. Excellent. Okay. Now, five x squared plus 3x minus 7. This is a trinomial. It has 3 terms. Terms are separated by addition or subtraction signs. The first term is 5x squared. The second term is 3x, and the third term is negative 7. Any questions about that? All right. The coefficient of a term is the number in front of the variable. So the coefficient of the first term is 5. The coefficient of the second term is 3. The coefficient of the third term is negative 7. Now, even though there's no variable in the third term, we could write something called raising a variable to the 0 power, which is equal to 1, and we'll talk more about that tomorrow. But point is, the coefficients are the numbers in front, all right? Now, let's say I have xy minus wz plus 12x squared. The first term is xy. The coefficient of the first term is a 1 because since there's no coefficient written, it's implied that there's one of them. Okay? So the coefficient of the term xy is 1. The second term would be negative wz. The coefficient of that term is negative 1 because, again, there's an implied 1 and there's also the negative sign. The coefficient of the third term is 12. Any questions about that? All right, now, I said that terms were separated by addition or subtraction signs. If we want to get really technical, terms are separated by addition signs. Let me explain. 12x squared minus 3xy plus 2y squared. Okay. The first term is 12x squared. The coefficient is 12. The second term is negative 3xy. Now, why am I calling it negative 3xy? Because if we take this trinomial and we write it so that we're focusing on the terms, we're going to write it as an addition problem. So it'd be 12x squared plus negative 3xy plus 2y squared. So by writing it as addition, now the coefficient becomes negative 3. Okay? So the second term is negative 3xy. Its coefficient is negative 3. The third term is 2y squared. Its coefficient is a 2. Any questions about that? Okay. Now, let's talk about the degree of a term. The degree of a term. The degree of a term, and we're talking an algebraic term, the degree of a term is the sum of all the exponents on all the variables in the term. 4x cubed. is a term of degree 3. So third degree because of the 3 on the x. 5x squared y cubed is 5th degree, not because of the 5 coefficient, but because of the sum of the exponents on the variables. 7y to the 5th is also a term of 5th degree because the sum of all the exponents on all the variables is 5. What about 4xy? Well, what is the exponent on the x? If you've got 1x, there's an implied 1 as an exponent. If you've got 1y, there's an implied y. So this would be 2nd degree, okay? So x is equal to 1 times x to the 1 power all over 1. So its coefficient is an implied 1, its denominator is an implied 1, and its exponent is an implied 1. Any questions on that?
I have one.
Yes.
So say that it's like 4xy to the 2nd. Would there be 3?
Yes.
Okay.
That would be a 3rd degree term
Okay. Thank you.
because you've got a 1 on the x plus the 2 on the y. You betcha.
Yeah.
All right. Any other questions before we go on? Okay. Let's see. Oh, let's say we've got 4x squared minus 7x plus 15. This is a trinomial. It has 3 terms. The first term is 4x squared. The coefficient of the first term is 4. The degree of the first term is 2. The second term is negative 7x. The coefficient of the second term is negative 7. The degree of the second term is 1. The third term is 15. The coefficient is 15. The degree of the term, and this is going to kind of boggle your minds a little bit, the degree of the term is 0. Now, I said earlier that I was going to talk about some rules from earlier on in the chapter on an as-needed basis. Here goes something we need to talk about, okay? Let's say we've got x cubed over x squared. If we expand that out, we have x cubed over x squared. We have 3 factors of x over 2 factors of x. If we reduce that down, the x over x reduces to 1 over 1, the x over x reduces to 1 over 1, and I'm left with x, or just x to the 1 power. There's a general rule that says when you're dividing 2 powers with the same base, so the bases in the numerator and the denominator are the a. If you're dividing 2 powers with the same base, you subtract the bottom exponent from the top exponent and attach it to the common base. So applying that rule to this situation, this would be x to the 3 minus 2 power, or x to the 1 power, which we can just write as x. Okay, let's look at a couple more examples of that. Y to the 7th over y to the 3rd power would be y to the 7 minus 3rd power, or y to the 4th power. Are you okay with that example? Okay, what about y to the 4th power over y to the 4th power? Well, that would be y to the 4 minus 4 power, which is y to the 0 power. But let's take that problem and deal with it a different way. Y to the 4th over y to the 4th. Isn't a number divided by itself equal to 1 unless it's 0 divided by 0? So wouldn't y to the 4th over y to the 4th be equal to 1? Or let's do it the long way. This would be y times y times y times y over y times y times y times y. If we reduce y over y, we get 1 over 1. Y over y, we get 1 over 1. Y over y, we get 1 over 1. Y over y, we get 1 over 1, which is 1 over 1, which is 1. So y to the fourth divided by itself is y to the 0 power. Y to the fourth divided by itself is 1. Y to the fourth divided by itself is 1. Well, if y to the fourth divided by y to the fourth equals 1, but it also equals y to the 0 power, that means that y to the 0 power equals 1. And from that, we expand on that, and we have a rule that says anything to the 0 power equals 1, except 0 to the 0 power, okay? So anything to the 0 power equals 1. So x to the 0 power equals 1. Y to the 0 power equals 1. Now, what does it have to do with anything? Well, let's go back. Let's see, back here. 15 could be written as 15x to the 0 power, because remember, x to the 0 power is 1. Now, why would we necessarily do that? Well, typically we wouldn't, but my point is this. 4x squared minus 7x, let's see here, plus 15 is the same thing as 4x squared minus 7x to the 1 plus 15x to the 0 power. We don't typically put this or this, but it's there if we need it. So thinking in terms of that, the first term is degree 2, the second term is degree 1, the third term is degree 0. Now, this can be confusing because if I say this is a term with a coefficient of 15, it's degree 0, you might think I mean that, which is 1. But we're looking at this through our algebra glasses. When we're talking in terms of algebra, we would say this is a term of degree 0, meaning that there's an implied 0 on any variable, or there's an implied 0 as an exponent on any variable. And I know that's a bit confusing. You'll get used to it. You'll be fine, okay? All right, back to things not quite so complicated. So let's see, we've got negative 5x to the fourth plus 3x squared minus 3x. So this is a trinomial. We can look at the degree of each individual term. The degree of the first term is 4, of the second term is 2, and of the third term is 1. The coefficient of the first term is negative 5. The coefficient of the second term is 3. The coefficient of the third term is negative 3. But now let's talk about the whole trinomial. The degree of the entire trinomial is equal to the degree of the highest powered term within the trinomial. So this was degree 4, 2, 1. So the highest powered term in this polynomial is 4. So we would describe this whole thing as a trinomial of degree 4. All right? Any questions there? Let's take a look at another example. 17ab to the fifth minus 12a cubed b. What kind of polynomial is this? Is it a monomial, binomial, trinomial, or just a polynomial in general?
It's a binomial?
Binomial, it has 2 terms. What's the coefficient of the first term?
17.
17.
Good. What's the coefficient of the second term? Be careful.
Negative 12.
Excellent. Negative 12. All right. What's the degree of the first term?
5.
Is it 6?
It's 6. Don't forget there's an implied 1 on the A, okay? So you can't just count the numbers you can see. You've got to think that. Okay, what's the degree of the second term?
4.
4, because again, there's an implied 1 there, all right? Now, so what's the degree of the entire binomial?
6.
6. Excellent. The degree of the entire polynomial is the same as the degree of the highest powered term within the polynomial. How about this? 12a squared x plus 3ab squared. What's the degree of the first term?
3.
What's the degree of the second term?
3.
What's the degree of the polynomial?
Would it be 6 or would it be 3?
Be 3. I got you. You don't add the different ones, but if it's a
Okay.
tie, just same thing.
Okay.
Okay. All right. Excellent. Let's see here. Now we're going to look at something called evaluating an expression. Let's say we have the expression x squared minus x plus 7. And we want to evaluate this expression for x equals 6. So what we're going to do is we're going to substitute 6 in the place of x, each place it appears in the polynomial. So we're going to get 6, the quantity squared, minus 6 plus 7. So I put 6 in the place of x in each term. So then I've got 36 minus 6 plus 7, 30 plus 7. So the value of this expression for x equals 6 is 37. Okay? Let's take that same expression and now let's evaluate it for x equals negative 6. So I'm going to get negative 6, the quantity squared, minus negative 6 plus 7. Now, I want to point out something. Let me change colors here. I didn't write that. That is not the same as that. This is negative 6 times negative 6, which is 36. This is 6 times 6 with a subtraction sign in front of it, which is negative 36. So they're not equal. Since this is x squared, all of x has to be squared. So in fact, let's see here. Let's go back and look at this. So what we've got here is negative 6 squared. So this would be a positive 36. Subtracting a negative is like adding a positive. So we get 42, 49. Okay? So be careful. This is not the same as that. Order of operations. Here you've got the base times itself. Here you've got the base times itself, but the base is 6, and then a subtraction sign in front. Okay? Okay, let's see here. How about this? Negative 10.3x squared minus x plus 6.5. We're going to evaluate this for x equals negative 1. So I get negative 10.3 times negative 1 squared minus negative 1 plus 6.5, which is negative 10.3 times, what's negative 1, the quantity squared? Well, negative 1 times negative 1 is what? Positive 1. Subtracting a negative is like adding a positive. So we've got what? Negative 10.3 times 1 is negative 10.3 plus 1 plus 6.5. Addition's associative as well as commutative. So I could add these two together. Let's see. When you're adding two numbers with different signs, what do? You subtract the smaller absolute value from the larger. And then you attach the sign of the number that had the largest absolute value, which would be negative. So this is going to be negative 2.8. And if you're relying on your calculator, perhaps you've forgotten how to do that. But anyway, so negative 10.3 plus 7.5 equals negative 2.8. Any questions there? Okay. Evaluate this polynomial. 4ab squared, where a is negative 2 and b is 3. So we're going to get 4 times negative 2 times 3 squared. Again, put parentheses around the substitution. So negative 2 is parenthesized, because if you wrote this 4 minus 2, 3 squared, people are going to think that's 4 minus 23 squared, and it's not. So be careful. Okay. Order of operations, you would do the exponent first. 3 times 3 is 9. Multiplication from left to right. 4 times negative 2 is negative 8. Negative 8 times 9 is negative 72. Any questions on that?
I have one question.
Yes.
So when you said a equals negative 2 and b equals 3, were those assigned to
Yes,
it?
those were assigned.
Okay.
Yeah.
I see. Okay.
So it seems like I just grabbed them out of thin air. In a sense, I did. I'm just doing problems out of the regular book. But
okay.
Yeah, so if they hadn't told us this, we wouldn't know what to do.
Okay, yes.
And then
All right, thank you.
some days, even when you tell me, I still don't know what to do, but that's another story.
All right.
Okay. So now we're going to go to some graphs, and hopefully I can get this to work successfully. We'll find out here. So I'm going to get rid of that, and I'm going to open this. And let's see here. We're going to change our background to a grid. And I'm going to do this. And let's see, there's 5 and 10 and 5 and 10 and 5. All right, can everybody see the grid that I drew, the graph?
Yes.
Okay, just making sure, because I'm never sure if I've pushed the right buttons at the right time. All right. We have this following equation. Y equals x squared plus 1. Now, again, I made reference to Math 95, or excuse me, Math 85, beginning algebra. In that class, or an equivalent beginning algebra class in high school or wherever, you should have learned to graph linear equations, which in fact we used back in, let's see, when we did 3.7 and 4.5, whatever it was, you know, graphing those inequalities, we used slope, intercept form, and all of that. But this is a second degree equation because of the x squared. And we're going to graph this, and we're going to do that by making a table. Whenever I am graphing an equation, and I don't really have any idea what it's going to look like, to kind of get an idea, I like to start with values of x going from -3 to +3. Actually, let's extend that out a little bit further. So I'm going to put different values in there. Let's see if I can clean this up a little bit. Okay, there we go. So I'm going to evaluate y equals x squared plus 1 for all those different values so that I get some ordered pairs. Okay, so if x is -3, y equals the quantity -3 squared plus 1, which would be 9 plus 1, or 10. Any questions about that? All right. for x equals -2. Y equals -2, the quantity, plus 1, which is 4 plus 1, which is 5. Let's see, let's get this out of the way here. Put this over here. For x equals -1. Y equals -1, the quantity squared, plus 1, which is 1 plus 1, which is 2. So if someone asks what you learned today, you can say you learned that 1 plus 1 is 2. If x is 0, y equals 0 squared plus 1, which is 0 plus 1, or just 1. If x is 1, y equals 1 squared plus 1, which is 1 plus 1, which is 2. If x is 2, y equals 2 squared plus 1, which is 4 plus 1, which is 5. And if x is 3, y equals 3 squared plus 1, which is 9 plus 1, which is 10. Notice something here. These two different x values have the same y value, as is true here and in here. So let's see what this graph is going to look like. Well, if I plot these points, -3, 10 is right there. Okay? -2, 5 is right there. -1, 2 is right there. 0, 1, 1, 2, 2, 5, and 3, 10. Well, one of two things has happened. Either I messed up really big time, or this is not a straight line. Well, fortunately for me, it's the second. It's not a straight line. A second degree equation is not a linear equation. The graph is not a straight line. Anyway, a second degree equation, it's a second degree equation, which is also called a quadratic equation. The graph of it is something we call a parabola. And it's kind of a smooth curve. So you don't want to take a straight edge and connect the dots. You want to make a kind of a smooth curve here. I say that. Let's see if I can do that this morning. Not very good. Didn't have my Wheaties apparently. So that's a rough picture of what it looks like. So that's a parabola. That's the graph of y equals x squared plus 1. Any questions about that? All right. I'm going to add a page here in just a minute. Come on. There we go. All right. And here, I'm going to do another example. And let's see, 5 and 10 and -5 and -10 and 5 and -5. Okay. And we'll move this over here for now. And now we're going to look at y equals x cubed minus 2. This is a third degree equation. It's called a cubic, as in cube. It's not going to be a straight line. It's not going to be a parabola either. Let's see what's going to happen here. Now, again, as I said, when I'm graphing something and I don't really know what it looks like, well, I do, but you won't necessarily yet. I'm going to start and go from -3 to +3. Once again. So if x is -3, y equals -3, the quantity cubed minus 2, which is -27 minus 2, which is -29. Wow. If x is -2, y equals -2, the quantity cubed minus 2, which is -8 minus 2, which is -10. If x equals -1, y equals -1, the quantity cubed minus 2, which is -1 minus 2, which is -3. If x is 0, y equals 0 cubed minus 2, which is 0 minus 2, or -2. If x is 1, y equals 1 cubed minus 2, which is 1 minus 2, which is negative 1. If x equals 2, y equals 2 cubed minus 2, which is 8 minus 2, which is 6. And if x is 3, y equals 3 cubed minus 2, which is 27 minus 2, which is 25. Well, I've got a couple of options. I could redo my graph. I could change my scale. I'm not going to do either one of those things. I'm just going to not bother graphing these 2 points, okay? So that I can fit it all on the grid that I made here. Okay, so if x is negative 2, y is negative 10. Oops. Okay, hang on here. Negative 2, negative 10. There we go. If x is negative 1, y is negative 3. If x is 0, y is negative 2. If x is 1, y is negative 1. If x is 2, y is 6. And what I get, again, is called a cubic, and it looks kind of like that. So it's sort of like half of a parabola, and then the other half is flipped over kind of thing. I mean, that'd be one way of describing it, but I kind of missed my dot there, didn't I? Anyway, so there's the graph of a cubic. Do you have any questions about that? All righty. So I'm going to stop the recording.